Hi folks, my name is Indra Sai Kiran Valluru, and this video is a part of our final project demonstration as part of our CS480 database systems course under Professor DS. So my teammates are Ajay Marampalli and Sai Nirmal Morampudi. So our the title of our project is DBS Food Waste Management Database. So I'll quickly show you my MAC address. Yeah, so here is my MAC address. And then I'll talk about our project description. So the main idea of our project was to design and develop a database which will be useful for restaurants to keep track of their items, sales, and employees for a restaurant, and which would help them to basically avoid the food wastage, which which happens a lot in restaurants. So they analyze this food wastage based on the item usage using items table, and restaurants can manage their inventory and employees appropriately. And they also sell products to users, which is the main purpose of running a restaurant. And users are also introduced to many offers using offer table, uh, which are on items provided by the restaurant, and a restaurant can also keep track of their daily sales, the daily profit which they earn, or something like that. So then I'll show you our ER diagram. So this through physical PNA. So this is our ER diagram. So basically, so restaurant is our main table, which is the primary table, like a strong entity, as we say. And then we have employee, delivery, users, offers, sales, and items. So we have many employees into a restaurant and many offers into a restaurant. So basically, all these are one-to-many relation. So as we have only taken a restaurant for this project to decrease our complexity, and there are multiple deliveries which are given out by restaurants, and there are multiple users logged in into a restaurant to order their food. So a restaurant has multiple offers, and these are the sales table, which indicates the daily sale amount, and this is our items table, which keeps a track of all the items present in our restaurant. So this end date is basically the expiry date, wherein we know the particular food is going into a wastage thing. So this is a brief idea about our ER diagram. So the restaurant ID is the primary key for the restaurant table, and all other tables have restaurant ID as the foreign key. And all the other tables specifically have their primary key. Suppose sales has sales ID as its primary key, offers as offer ID as its primary key, user has user ID, and all other variables like employee ID, item ID, and all. Next, I'll quickly show our initialize DB. How do we initialize DB? So I'll run our main JSP on the server. Finish. So we'll log out from this. So this is our main the front end part of our project. This is our main UI page. Now I'll show you my workbench. As you can see, there are no tables inside the DBS food waste management database, as we have not initialized our database. So I'll quickly initialize the database and show you how it populates all the tables. So you go click initialize DB, and we just give a user test, and then login, and then we see, we refresh this workbench. Yeah, as you can see, all the tables have been populated, and all the tables have been created using the initialized DB. So next in this project, so this is our Eclipse. So this is our initdb. So yeah, so this is our initdb SQL script which we used for creating the tables as I showed earlier. So this table creates, this is the create statement which creates a restaurant table. Restaurant ID is a primary key, uh, which is mentioned here. And these are the unique indexes created for the primary keys. So the start time of the restaurant, end time of the restaurant, restaurant addresses, another variable, and a restaurant name. And there is this another table which is employee. So employee ID is the primary key here, and restaurant ID is the foreign key. So yeah, see, the foreign key basically it refers to it gives a reference to the restaurant table. And so as you can see, there are two unique indexes created for employee ID and restaurant ID, which are primary key and foreign key constraints. And this is our constraint which we have defined as constraint underscore one, which refers to the restaurant table for the foreign key restaurant ID, and cascade options like on delete there's no action and on update no action. We have given on delete no action because if we delete the restaurant ID, all other tables are dependent on the employee table, user table. Every table is dependent on the restaurant ID. So we do not want any action to be done on delete. So that is the part of initialize DB. I'll quickly go through the other tables also. So this is a users table where user ID is the primary key, order date is mentioned, user phone number, user address, user email, and restaurant ID is here, the foreign key. And then delivery ID is the primary key here, and restaurant ID is the foreign key. So some other attributes like delivery date and time, delivery address, delivery cost. And then we see offers here. So offer ID is our primary key and restaurant ID is our foreign key, and the offer item name, the percentage discount which is available in the restaurant for that particular item. So again, the constraint is same, we create it on the foreign key because restaurant ID is a strong entity in the primary table. So we do not want anything, no action to be done on delete or on update. So basically next to sales is the next table. So sale ID is our primary key. Here we talk about daily sale amount, which is the overall sale by a particular restaurant on that particular day. So sales report, which we can retrieve from particular days, like for a week or something like that. This is the profit which will be calculated based on the daily sale expenditure and all. So restaurant ID here is the R foreign key. And then as we can see, items is another table, item underscore description is another table, and we can go on. So next I will show talk about so I was in charge of offers and items. So I'll first go create an offer team offer. So offer ID I'll give one or two. Offer item name I'll just give a is QZ, percentage discount 10, restaurant ID for one. So I'll create this offer. So I just created this offer. If we go to SQL Workbench and if I see offers, so as you can see, if I run this offers table, so this is our offer ID 1 or 2 or ADZ which I just gave in. So the percentage discount was 10 and the restaurant ID was 1. Now I'll go and basically read this offer. So offer ID was 102. So read this offer. So you can see the values are displayed here, which I gave in ADZ 10 1. Then I'll go and update this offer 102 was my primary key. So this was our primary values. I'll just go given some more. change the item name and percentage discounts to 30. Update offer. So now I'll go through my SQL workbench and just again run my queries. So as you can see, the offer item name is changed, the percentage discount is to 30, and the rest all the conditions are same. Now I'll just go and delete this offer. So 102 was my offer ID. I'll just go delete offer. So offer is deleted. We'll go to the workbench. Again run this query. As you can see, the offer has been deleted. So I perform all the CRUD operations. Now I'll go through the code part of it. So how do we implement these CRUD operations? So Java, so offer, yeah. So this is basically the servlet page where we do the front end part, where the on front end it was mentioned as create offer. This is basically the servlet page which was used to create that. So in now, if you go to offer Java, so this is basically the find by offer ID. So it is basically if you want to find an offer ID, if suppose I give 1 or 2 as an offer ID, so it will fetch me all the details of the item name, offer, discount, everything. So this is basically the create function which was used to create an offer. So this add function is basically the create function which was used to create an offer. So this is our SQL insert statement. Insert into offers. Offer ID is the primary key. We just given the item name, percentage discount, and restaurant ID, and the values were put in. Then for update, so for update, this is the function. So basically, we update offers set offer item name to whatever we change the value in, and a percentage discount to whatever the change we value, the values were changed. So here offer ID and restaurant ID can't be changed because those are the primary key and foreign key. So we can only update the offer item name and percentage discount as shown earlier. So this delete function is used to delete the offers. Basically delete the, on the basis of offer ID. So you just given the primary key, which is offer ID 1 or 2, and as I showed earlier, it was deleted. So next I'll go through another CRUD entity, which is the same items. So I'll say create item. So I'll show you the workbench first. So this is the items tab. So item ID third. This is our items basically. I'll create one more item. This is item price. What shall I use? Muffins. Item, and let us just copy it from here. So this will create an item. I will show you on the workbench. So as you can see, the muffins is added. So for this, I'll show you the particular for here. So this was for offers. This is for items. Item start job. So to add this particular item, we use this query insert into items, item ID, item price, item name, item in date, and item expiry date. So item ID here is the primary value, primary key. Sorry. Next, we go into items and read that item. So iPhone 36 is our item ID. The items. As you can see, the item price which we mentioned 200 muffins and the expiry date are different here. So for this, reading the query, We use find by item ID, where we fetch in the details of the particular item, the price, the expiry date, and all with the item ID, which is our primary key. So this function is used to read the values. And then if you go to update this item, so 36 was our item ID, so we want to update our items. So let's suppose we want to update our muffins to basically dumplings, and item price becomes 2000. We just update our items. It shows items updated. We go to our SQL workbench and we execute the query. As you can see, the item ID 36. Now the item price becomes 2000 and the item name is dumplings. The offer has been updated. For this, we have used this function void update. We have used this function update, and our SQL query is update items, set item price to this, and item name and item in date or expiry date. We can change all these four values except item ID because that is our primary key. Using that, we can update our item attributes. Next, we'll go and delete this item. So delete items. So item ID is 36. We will delete items. Items is deleted. Go to workbench and you can see the item ID 36 is deleted from this, and in our DB it is updated. So for this, I'll show the function. So this is our delete function. So delete from items where item ID is the primary key, and we give him the primary key value, which basically deletes the item from the DB. So I'll talk about the remaining sections where we implement a simple query, an aggregate query, and a complex query. So we click on this query results. So I've worked on one simple query and one aggregate query and a complex query. So my simple query is this one, which lists all the offers with offer ID greater than 27. So the basic query for this is, I'll just show you the query. Yeah. So it selects from offers table where offer item name is given as just a like function. We have used this where offer ID, which is this is our main functionality, where offer ID is greater than 27. So this is our basic query. I'll show you the result here. So 28 and 29 are the offer IDs greater than 27. So in Workbench, if you go to the offers table and if we execute this, as you can see, there are only two offers which are greater than 27 offer IDs which are greater than 27, 28 and 29. We'll quickly go through the code. How do we implement this SQL query? So for offers, it goes, so the main business logic stays in offer DAO.java. So as you can see, this is our basic business logic for that function. So as you can see, find offers. So we create a list and this SQL query is implemented here where select star from offers, where offer item name is just given a like function with ampersand a, and where the offer ID is greater than 27. So offer domain, new offer, an object is created, and to this object we initially we set the offer ID value which we get from the result set. We set the offer item name, percentage discount, restaurant ID, and we add all this object attributes to a list. So if you go to the service part, so here if you see, so find all through, so this function is used as I mentioned in offer.dow, the find offers functions where we get the offer list of all the offers with their percentage discount, item name and all greater than 27. This is our service part. And the front end part is here. So if you go into the servlet JSP page, so this is our front end part where offer query executes that query. So we simply extend this with HTTP servlet, and we just give this is basically the front end part of the query thing. So my next aggregate query is using string functions. So it lists all the items uh, and it converts those items given in that string into a lowercase string, and also it concatenates with a word called modified. So this function is basically used in this project because we want to uh, 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 like uh, in a restaurant's perspective, we want to know if this product was waste, and they have modified this in order to send it to some orphan place, or to send it to people who are in need food. So this is the basic functionality of this query. We just modify the item name. So I'll show you the results. So as you can see in this result, so if pizza is an item name given, even if P is capital, it is using lower underscore string, it is converted into a small into lowercase string, and then we concatenate this string using modified thing. So it just gives you modified pizza. So I'll just quickly give you a demonstration of this. If you go to items table and create items, item ID, items table. So I'll give 35 as item ID. 300, 3000. Muffins, I just give a capital M here. So I just copy this item and paste it here. We create this item. So if you go to the workbench and execute this query again, so this item is created. So if you go again to our application and go to this part and click this query, so as you can see, there's one more item added here, which so while inputting, we made sure that M was capital, so now it was converted into a lower string, and then it is modified to modified.muffins. So I'll show you the code part for this. So I'll show you the query first. Query. So yeah, so this is our query. So you use concatenate modified thing for the item name as concat string, and the lower dot item name as to convert into a lower case string, where the item price is greater than 200. So as you can see, our item price was somewhere around 2000 or 3000, so it is greater than 200. So those strings were converted into lowercase and concatenated. So the code part here is, if you go to the items block, items Java. Yeah, so you can see this find item query too. So this was the method or function which we used. So here you can see the SQL query, the concat, which I just explained it earlier, the concatenate function and the lowercase function, where the item price is greater than 200. So similarly, we just create an object for item query 2, and get those values from the result set, and add it to the item query 2. So this is our service block. So find item query is, we call that in service using the DAO function, where we implement our business logic. And this is our front end part for this particular query. So this is so it basically adds those the added items in that list to show it up on the front end part. So then I'll quickly go through the third query, which is our complex query. where it is like list all restaurant and delivery ID on same restaurant ID. So the basic idea of this was, so to basically, if one restaurant has multiple delivery IDs, so if a particular restaurant gives multiple deliveries, so for a particular restaurant, if the restaurant ID is same, then it should show all their deliveries from that particular restaurant. So I'll show you the query, execute the query. As you can now see, there are 5 different restaurants and their delivery IDs are these, and the delivery address are this. So if I add another delivery ID with the same restaurant ID, like if suppose I create one more delivery ID with 26 and the restaurant name Adda, which has restaurant ID 2, so it should create one more tabular row in this indicating that. So I'll just show you by creating one. So if I go to delivery and create one delivery ID, 26, delivery date and time. So go to the workbench and simply copy that. A, B, C, D, E, F. Red process. Sorry, 100. Restaurant ready is 2. So I just created this delivery. So if I go to query results and execute this query, so you can see my new delivery ID, which I just created now 26. So with the restaurant ID 2, which indicates Adda restaurant. So one more delivery ID is created under the restaurant name Adda, and you can see the delivery address is also updated here. So I'll show you the code part for this. So this is our queries part. So we have just basically used a left join function on like left join function from restaurant to delivery, basically giving that left join condition on restaurant ID, which is the primary key of restaurant table and the foreign key reference of the delivery ID. It's a basic simple left join query which fetches us all the delivery IDs for a particular restaurant ID and a restaurant name. So how do we implement this in DAO? So if we go to the restaurant DAO, yeah, as you can see, so this, yeah. So this is our function. So filed all our delivery IDs with respect to the restaurant ID. So this is our function. So we create an array list, and then the string SQL command is select restaurant name, delivery ID, delivery address from restaurant, left join delivery on the delivery dot restaurant ID and restaurant dot restaurant ID, which is basically the primary key of the restaurant ID, as I mentioned earlier. And this is the foreign key. Restaurant ID is a foreign key reference on the delivery table. So we just create an object here over here, and then get those values and set it to the this object and add this object to the list. So then if we go to the service class, we call this function which was implemented in DAO. So the find all function was implemented in DAO. So we just call this thing. And for the UI part, so for the front end part, we just go to this restaurant query and extend this HTTP server page. And here is the font. So the list is created here. So the list is fetched here. And it's a basic for loop which contains that. So this is how you implement all the simple query, complex aggregate query and complex queries. So coming to the conclusion part, I just want to show the contributions of our project. So this is our GitHub project. If you go to the insights part, contributors. So Ajay has 38 commits, Sai Nirmal Morampudi has 35 commits, and myself in the SK have 31 commits. And we divided our project into like we had 6 entities, so we divided two per person. So I was handling items and offers entities, and my colleagues were handling the rest of them. And we segregated the front end part according to the entities, and also the back end part according to the entities, and we divided it equally. So the three things which I learned from this project are implementing the business logic. As I mentioned earlier, implementing the business logic for the queries in DAO.java class. So that was kind of new for me. So which helps you do the backend, which that DAO.java helps you to connect the front end and back end part and implement your queries and fetch values from those. And one more thing which I learned from this project was creating proper logical design and physical design. So in order, uh, as this is like a type consumer project, in order to be on the path of a specific goal of the project, you need to have a proper logical design. So you need not be confused of what entities have what relationships and all. So those things help me a lot during this project. So one thing which we would like to have in our project was an inventory table, but due to the time constraint, we couldn't add it one. So inventory is basically a data warehouse thing, warehouse thing, where a restaurant can store its the food which is not wasted actually. So which helps them to store the food which is not wasted, and give them it to needful people or NGO organizations. So we would like to have that inventory table wherein the restaurant can track the size of the inventory, the available space at the inventory and all. And some modifications which I feel would have been very good, like implementing the front end part in React JS, but due to time constraint, we couldn't do that. And our application can be used by several restaurants here in multiple countries. And the basic motto of our application is controlling the waste management which happens at restaurants. Uh, Looking closely, UIC Dining Hall can also implement our application if it intends to do any deliveries or maintains any employees for that. So that's it from our end. Thank you.